Hello class, welcome to the next segment in the week 9 material. And in this segment, we're going to actually take a look at how we can use arrays inside of a Python program, again, as opposed to using a regular Python list, which may not be desirable. But here we're going to actually take a look at how we can make use of arrays inside of the Python programs that we write. So to start off with, and this is something that's very important to mention, in order to actually make use of arrays, you have to import this module called NumPy. Some people also call this NumPy, but you have to make sure this module is imported inside of your Python program somewhere. Otherwise, you're not going to be able to use these arrays, which offer several advantages over Python lists. And another thing that you will very commonly see is you'll see import, the module name itself is called NumPy, but in the case of long module names especially, some people will elect to say import module name as something else. And basically the way this works is it sort of creates an alias, and it sets it up so that wherever the computer finds this particular character sequence, it knows we're talking about this module. So down here we have np, which is the same character sequence that we have over here to the right of the as keyword. So wherever, because we've used the as here, this way the computer knows that wherever it sees np, it knows we're really talking about the NumPy module. So what this allows you to do is you can take really long and cumbersome module names and rename them to something that's a lot shorter and a lot quicker to work with. And when we talk about the matplotlib module, this will come into play as well, because the matplotlib module name is ridiculously long, and it's nice to be able to shorten that into something that's easier to work with. So that's what's going on here. The module itself is called NumPy, but by having the as word here, we can sort of rename that module to something else, and that way the computer, we can work with things a little bit, we can make things a little bit more compact, and that way the computer knows that when it sees NP, it really knows we're talking about the NumPy module here. Now, to actually create an array, we have to do sort of an intermediate step first. We first have to create a Python list, and then there's this function inside the NumPy module called array. So kind of like the math module, there are functions inside the math module that do all sorts of things. And what we can sort of do the same thing with the NumPy module. Say go into the NumPy module, find this function called array, again, module name, shortened up here, module name dot array, and then we give that function a list, and that list will be then converted into an array, and then we take the resulting array we get back from that, and it goes on the left hand side of the equation here, or on the equal sign I should say. So Python list here, that's what we start off with, and then we convert that Python list into an array, which is what this does, and then that array then goes on the variable that we have on the left hand side, the equal sign here. And in the case on line 7 here, we're taking a two-dimensional Python list, works pretty much the same way. We just simply put inside this function what we want to be converted into an array, if possible. So here we put in a two-dimensional Python list that gets converted into a two-dimensional array. In this case, that goes on the variable on the left-hand side, the equal sign here. And again, the rule of thumb that I like to use here, however many open brackets you see at the beginning, that's how many dimensions are inside of that Python list or array. So in this case, we have 3 open brackets in sequence here, which would suggest that we have a 3-dimensional array or a 3-dimensional list that we're going to be converting into a 3-dimensional array. Same process as before. The entire list goes inside of this array function. In fact, if I want to show you what the entire list looks like, it's very long since it is 3-dimensional. So it does take up a fair amount of screen space, but it's the same exact process. We simply take that, put it into the numpy.array function, and that just simply is converted into an array, and that goes on the left-hand side of the equal sign here. And if we want to see how exactly this is treated whenever we go to work with this, so here we can say print out whatever one dim is, so we can see what exactly is stored in there, and you can see it prints out something that looks a lot like a Python list, but one significant difference that should be noted right away is when you go to print out a list, the individual entries will be separated by commas in the console. If you're working with an array instead, those commas will actually disappear. The entries will actually be separated by a blank space as opposed to be separating by a comma. So if you printed out an array, you'll just see the blank space. If you printed out a Python list, you'll see commas separating each individual entry. So that's again one of those subtle differences between arrays and lists that is something that's fairly important to keep in mind so you're not confused about what exactly you're working with. And if we want to, we can see what our two-dimensional array looks like. So again, And you can, one of the nice things about this is it automatically prints it out in sort of like a table format in terms of rows and columns. And that makes it a lot easier to interpret whenever you're going to put this information in the console. So just like before, when we were thinking about in terms of rows and columns, you can see I'm highlighting the rows here, and then the individual columns are also involved there, and we'll actually demonstrate how to access those individual entries. But one thing I also want to show is what our three-dimensional array looks like when we go to print out what that is. And you can see how this is the result that we get. Now, I mentioned in the previous video how it's helpful to think in terms when you're working with a three-dimensional data set or a three-dimensional array, it's helpful to think of it in terms of stacks, rows, and columns. And in this case, we have a stack. This should also be considered a stack, and this would also be considered a stack. You can almost think of this as like a stack of papers where you have a grid of numbers written on one piece of paper, and on top of that, you've got another piece of paper with this grid of numbers, and on top of that, you have another piece of paper with this grid of numbers. And if we want to, we can actually take a look at how to access individual entries inside of these arrays. So whether it's a one-dimensional Python list or a one-dimensional array, if you're working with something one-dimensional, then you access individual entries in an array exactly as you would a one-dimensional Python list. So in this case, we're interested in entry number one. If we want to see what our array actually looks like, what one dim looks like, there it is, just highlighted in the console. So again, the computer starts counting at 0. So this would be entry number 0 in the array. This would be entry number 1, and this would be entry number 2. And so if we put the 1 in the brackets here, we want entry number 1, which should be that 4. And let's see if that's the result we get. And you can see we can in fact confirm that to be the case. Now we go to our two-dimensional array, which we printed out here. So kind of like what we had when we were working with a two-dimensional Python list. So main difference here is, again, we don't have multiple sets of brackets with an array. With an array, we have one set of brackets and the individual dimensions are separated by commas. So in this case, this would be the row number that we're interested in, this number to the left of the comma, and this would be the column number that we're interested in. In the case of this two-dimensional array, this would be row number 1. Again, keeping in mind the computer starts counting at 0. This would be row number 1, and this would be column number 1, what my mouse cursor is going over. And if we take a look at that, the number that corresponds to row number 1 and column number 1 would be this 13 here. So if this in fact works just like it would with a two-dimensional Python list, you can see it does in fact give us that value of 13. So just like a two-dimensional Python list, with the exception of the brackets, the formatting is a little bit different, but the functionality is essentially the same. So again, I'll go ahead and reemphasize this because I even make this mistake sometimes because it's really easy to conflate the two. But whenever you're working with a two-dimensional Python list, we have one set of brackets for each dimension. When you're working with a multi-dimensional array, you have just one set of brackets. Doesn't matter how many dimensions, you're just going to have the one set of brackets, and then the individual dimensions are separated by commas. So again, this would be the row that we're interested in, and this would be the column that we want to pull out. And if we want to go to the three-dimensional array, so again, that's the three-dimensional array that we're going to be working with here. So we still are going to be working with in terms of rows and columns, but we also have to worry about which stack we're interested in. And in the case of a three-dimensional array, it's helpful to think of this in terms of stacks, rows, and columns. And the order that it goes here is the first number. Again, we just like before, we still have the one set of brackets. This would be 1 dimension, 2 dimensions, 3 dimensions. When we go to put it turns out that this number corresponds to the stack that we're interested in. So this stack number, again, the individual dimensions are separated by commas here. This stack number of 0 means I want stack number 0, which is this assortment of numbers here. And then out of that stack, I want row number 1 and column number 1, which would correspond to this value of 14 here. So again, stack number 0 matching up with this 0, row number 1 matching up with this 1, and then column number 1 matching up with this one, this column, which would give us this 14. And we can confirm that with a simple running of this print statement. You can see we get that exact same result. And if I want to sort of break up the ambiguity here, so this means stack number 0, row number 1, column number 2. We go back to our three-dimensional array. We're still on stack number 0. still in row number 1, but now we want column number 2, which should be this 18 here. And if we want to run that, we can in fact confirm that is the exact same result that we get. Now, something else you can also do to to make your life a little bit easier, because right now I'm just stating the list exactly, I'm stating it explicitly, but if you've already got a variable that is holding onto a Python list of sorts, what you can do to convert that to an array is to do the following. So you simply use the array function like before, except instead of plugging in the list outright, you just plug in the variable that's holding onto your list, and that will in fact convert your list to an array. So if I want to use some of the print statements here to show how these are treated differently, so this will print out the original list that we have up here, and this will print out that result converted into an array. And you can see when I print this list out, you can see how I still have the brackets, but the individual entries are separated by commas. In the case of the array, the commas are not there. The entries are just separated by blank space. And if you want to convert from, say, an array to a list, which might be desirable depending on what you have in mind, so I could take one of these arrays that I have up here. Let's, for the sake of simplicity, just convert one dim into a list. That utilizes the list function, which is a built-in Python function. You don't need an import statement to use it, but we simply take the name of the array that we want to convert into a list, plug that in the list function, and the resulting list goes on the left-hand side of the equal sign here. So again, if we want to compare these two, print out one dim versus as list, which should be holding onto a list now, and we can see again, this print statement corresponds to an array, and we know it's an array because the commas are not there. And now we see it is in fact being treated as a list, hence the second print statement, and also hence the commas here separating each individual entry. So that's sort of part one on some of the stuff that you can do with arrays. And right now we're just focusing on putting individual numbers inside the brackets here. In the next segment, we're going to talk about something that you really need to watch out for with arrays, and we're also going to take a look at how we can incorporate the slice syntax into arrays, which can get kind of complicated and kind of interesting. But that's something we'll tackle in the next segment. So with that, I will see you all in the next segment.